Hello, chemists. It's Jolly. Let's talk about reactions. Gonna go to the notes here. All right, so chapter 9, at least it's chapter 9 for me, but we're talking about reactions. And there's just a few types of reactions that we're going to learn this semester. But before we can do that, we have to learn something about electrolytes. And so we're going to start off talking about what an electrolyte is, what it isn't, and some of its purposes. And then we'll talk about different types of equations, and then we'll do some reactions, how to write the reactions, and then the last type of reaction we'll call redox reactions. All right, there's one handout for this one, and it is the electrolyte and reaction handout. All right, let's get started. Before we can start doing your prediction of reactions and products, we need to know some of the species. And so we're going to call some of those electrolytes. Now, what in the world is an electrolyte? It is a substance that conducts electricity when dissolved in water. All right, now that's the key, when dissolved in water. Or melted, but the ones that we're going to be playing with is dissolved in water. So most ionic compounds, okay, which is called dissociation, which means being dissolved in water, and some molecular compounds that create ions inside of the water. The key here is it has to conduct electricity, so it has to have ions. And there's really only going to be two ways, dissolved in water or a melted ionic. Now, literally melted, and it takes a lot of heat to melt anything ionic. So we're going to be dissolving in water. Anything that does not conduct electricity after it's dissolved or melted is called a non-electrolyte. Notice I do also put or poorly. And then we're going to talk about, well, if I determine whether it's an electrolyte or not, what is its strength? Is it strong? Is it weak? Is it not? All right, so I'm going to give you two variations. One is going to be strong and one is going to be weak. A strong electrolyte, it exists almost entirely in its ionic form. So when it dissolves, it's pretty much 100% as ions. Weak is anything less than 100%. Okay, so we're going to stick with that definition. Strong pretty much is 100% dissolved, and weak is anything less than 100%. Now, that doesn't mean that it can't conduct electricity fairly well. We're just talking about how much that it dissolves in the water. And how are we going to decide this? We're going to use the solubility rules. And yes, these are on your reference sheet. So your solubility rules are going to help you decide whether something is going to dissolve in water. Key point right here. I am talking about ionic compounds, not molecular compounds. All right, so let's talk about these solubility rules. When you're looking at the top one, the way you read it is like this. So water-soluble compounds. Everything in group 1A or column number 1, all compounds of the alkali metals are soluble. End of statement. There's no exceptions. Ammonium, all ammonium compounds are soluble. End of statement. Nitrate, chlorate, and perchlorate are all soluble. No exceptions. Acetates, all acetates are soluble. No exceptions. Now, if there's an exception, this is the way you would read it. All chlorides are soluble except silver 1 chloride, lead 2 chloride, and the mercury 1 polyatomic chloride. So these AgCl, PbCl2, and Hg2Cl2, those would all be considered insoluble. Anything else? So what about iron 2 chloride? This one would be soluble, but these are insoluble because it's an exception. So for bromine and iodide ions, they're all soluble except the silver, lead, and we're going to add in the mercury +2. All right, fluorides, I'm going to add in some magnesium, calcium, strontium, and barium, and then I'm only going to keep that lead from the ones above. And then the sulfates. All sulfates are soluble except the silver 1, lead +2, calcium, strontium, the mercury 1 polyatomic, and barium. All right, so that's the way that you would read the top. The bottom, the way you would read it is all sulfides are insoluble except, and so these stand for columns, except column 1, column 2, and ammonia, which makes perfect sense because there's column 1, there's ammonia, And then column 2 happens to be our alkali earths. So all sulfides are insoluble, except all hydroxides and metal oxides are insoluble, except column 1, barium, strontium, and the calcium ions. And then I make a note. When metal oxides dissolve, they give hydroxides. So for instance, sodium oxide, when you put that in water, really what you made is sodium hydroxide. So they're kind of like two sides of the same coin. And then last but not least, carbonate, phosphate, and sulfite. Those are all insoluble except column 1 and ammonium. All right, we're going to be playing with these, but let's just do a review before I go off this page. What is an electrolyte? An electrolyte is a substance that conducts electricity when dissolved in water or when it's melted into its ions. Most ionic compounds, and when they dissolve in water, it's called dissociation. And there are a few molecular compounds that will create ions in water. That's called ionization. We will play with those two terms a little bit later. If it does not conduct electricity after it's dissolved in the water, we call it a non-electrolyte. And there's two strengths. It is either a strong electrolyte, which means it dissolves pretty much 100%, or it is a weak electrolyte, which means it's anything less than 100%. How are you going to know whether they dissolve 100% or not? We're going to use our solubility rules, and these are on your reference sheet on the green pages, and then we would work through whichever compound is given to us. But I'm going to move this out. But we are going to jump over to, let's see, stop sharing here. Hold on, I'm going to use this one in a while. I'm going to get to part of the handout. Let me see, we're doing electrolytes. Look at that sharing it. Go back to it. All right, this is the first page of the handout for the electrolytes. So we're just going to do a few of these. So you need to be looking at your reference sheet. All right, so the ultimate question is it an electrolyte? And if it is an electrolyte, is it strong or is it weak? So what am I looking for? All ionics are electrolytes. Okay, so all ionics. So all ionics are electrolytes. All moleculars are not electrolytes except ammonia, NH3, and acids. All right, that's going to be our mantra first. Is it ionic or is it molecular? Okay, so let's start with this first one, sodium chloride. Question number 1, is it ionic or is it molecular? All right, sodium chloride is ionic. Well, because of that, it is an electrolyte, because all ionics are electrolytes. Because it is an electrolyte, then I can answer these last two columns. So I need to answer this to get that one. All right, so sodium chloride. I'm looking at my solubility rules. All sodiums, everything in column number 1 is soluble. Now I'm looking at the chloride. All chlorides are soluble except, well, sodium is not one of my excepts. So I'm going to say this is 100% soluble. And if it's 100% soluble, that means it is a strong electrolyte, which means it's pretty much 100% sodium ion and chloride ion floating around in water. Okay, let's go to the next one. Step number 1. Is it ionic or is it molecular? Okay, so lithium hydroxide is ionic. So therefore, it's an electrolyte. So I need to ask, is it 100% soluble? I'm looking at either the very top again or underneath. So this is column 1. This is an alkali. All in column 1 are soluble. End of statement. But if I go down, all hydroxides are insoluble, except column number 1. So this one again is soluble. So that makes it strong. All right, ammonium sulfide. Ammonium sulfide. Is it ionic or is it molecular? Well, this is a poly and an anion, so it's ionic. Well, all ionics are electrolytes. I just need to know whether it's soluble or not. So all ammoniums are soluble, end of statement. So that makes it strong. All right, next, SO2, sulfur dioxide. Now this one's molecular. So I do have to ask the question, well, are you an electrolyte? And I'm back up here. All moleculars are non-electrolytes except ammonia and acids. And so I need to ask myself, is that ammonia? Well, the answer is no. Is that an acid? No. How do I know? Because remember, acids have a hydrogen on the left. And so this is just molecular, so it's non-electrolyte. And you don't answer these two columns if it's molecular. All right, next, calcium chloride. Step number 1. Is it ionic or is it molecular? It's ionic. All right, I hope everybody right now is going, oh my goodness, this feels just like when we did nomenclature. Yep, that's one of the reasons I pushed nomenclature. All right, it's ionic, so therefore it is an electrolyte. Oh, well then I have to know whether it's soluble or not. So I go to my solubility rules. All chlorides are soluble except, this is not one of the excepts, so it is soluble, which makes it strong. All right, leave a few for you guys. Let's go down to water right here. Step number 1. Is it ionic or is it molecular? Well, it's molecular. Ah, all moleculars are non-electrolytes except ammonia and acids. Well, this is not ammonia, but guess what? The hydrogen is written on the left. This is an acid, so this is an electrolyte. Okay, that is an electrolyte. Now, the only way that you're going to determine whether it is strong or weak has nothing to do with the solubility rules. Okay, the solubility rules are for ionic compounds, and this is not an ionic compound. This is a molecular compound. So we need to know something about those molecular characteristics. And I don't know whether it always swaps, so I'm going to close out and then go back. All right, I'm zooming back in the notes, just so that you know where I'm talking about. We talked about what an acid was a long time ago, but I have a little review right here for you. What is an acid? An Arrhenius acid, it has a substance that produces a hydrogen ion, okay, H+, in water, or a Bronsted-Lowry. I'm going to talk about these more when I get to this page, but we're going to use this definition. And so an acid is a species that donates a proton, which means it has a proton on the left. Technically, that's called an ionizable proton. And you can have more than one, but you have to have a hydrogen written on the left. And there's really only 2 types of acids. You can have strong acids and you can have weak acids. And the beauty of this is there's 6 strong acids. And there happen to be 6 strong bases as well, but we're playing with acids right now. There's only 6. All others are weak, okay? Anything that's not in this list of 6 is considered weak. So perchloric, sulfuric, nitric, hydrochloric, hydrobromic, and hydroiodic, those are not listed on your reference sheet for you, okay? That's a memorization, or you'll just know them here in a little bit. But those are your strong acids. Strong acids are strong electrolytes. Weak acids are weak electrolytes. And ammonia is a weak electrolyte. Okay, let's go back to our handout here. Okay, let's ask our question about water again. Oh, water's molecular. Is it an electrolyte or a non-electrolyte? Well, all molecular compounds are non-electrolytes, except, and this is one of the exceptions, because it's an acid where hydrogen is written on the left. And now I need to ask, not this, I'm not asking whether it's soluble. I'm asking, is it strong or weak? And so, is it one of the 6 strongies? And the answer is no. So this one is a weak electrolyte. All right, let's go down to HF. That is molecular. And remember, by definition, electrolyte means dissolved in water. So that means AQ. All right, so it's molecular. All moleculars are non-electrolytes, except this is an acid, so it is an electrolyte. And then I have to ask myself, not whether it's soluble. I just have to ask, are you one of my 6 strongies? And HF is not one of my 6 strongies. So let's see. Let's go to this one. Hey, look, it's also molecular. It's an acid, so it's an electrolyte. I'm not talking about solubility. Is it one of my 6 strongies? Yes. Nitric acid is one of my 6 strongies. So in that case, I'm going to put strong. All right, now this entire table is literally to get you to see first ionic, then molecular, and then ask the question, is it an electrolyte or a non-electrolyte? And if you decide that it is an electrolyte, where are you going to look to decide whether it is strong or whether it is weak? And there's a lot of options for you to play with. Okay, a lot of options. Why so many? It has to be instinctive. So remember, we're using this to build up into predicting reactions. So we really have to understand the characteristics of these chemicals. All right, let's go back to our page here. And I'm going to go to my whiteboard and we're going to play with these electrolytes. All right, so what do we know? An electrolyte. It conducts electricity. All right, well, what things conduct electricity? One, melted ionics. Very hard to do. Remember, ionics have very, very, very high attractions between the ions. Melted ionics. So for instance, sodium chloride salt, solid, if you melt it, it can be turned into sodium ion and the chloride ion. Notice I'm not putting AQ right there. I'm putting an L. It literally is melted. It's pure molten salt. Those are ions. It would conduct electricity. Also, if it's dissolved in water. All right, well, who can dissolve in water? Lots of things can dissolve in water, but I want to know which ones can dissolve in water and also produce ions. Okay. Well, guess what? All ionics. They might not dissolve very much, but they will dissolve into ions. So all ionics will be an electrolyte. There's my A. And B, moleculars. There's not very many. The moleculars, 1, ammonia, and 2, acids. And we just learned that the term acid means ionizable hydrogen or hydrogen on the left. Right, there's our 2 possibilities. Hey, are you an electrolyte? Well, can you conduct electricity? And the answer is, well, if I'm a melted ionic, yes. Or if I'm an ionic inside water, or if I'm ammonia dissolved in water, or I'm an acid in water. Okay, those are your electrolytes. All others are non-electrolytes. Okay, there's one question answered. My next question is the strength. And there's only two strengths for us. One, a strong electrolyte is pretty much 100% ionic when it is in liquid form, okay? And we're not talking about melted ions, so I'm going to say 100% ionic in water. Oh, well, which ones are those? A, all soluble ionics, and B, the 6 strong acids. Weak electrolytes pretty much are everything else. Are insoluble ionics and everything else. Except the 6 strong acids. Okay. That was a whole bunch of, why are we learning? Get back to my notes here. Oh, you know what? That might not be showing me. All right, go back to the beginning here. All right, what is an electrolyte? We talked about it has to be able to conduct electricity. Well, when can it conduct electricity? Whether it is in its molten form or when it's dissolved in water. Well, what things can dissolve in water? Okay, all ionics can dissolve in water. So all ionics are electrolytes, but some of them dissolve 100% and some of them don't. So we're going to use our solubility rules to determine whether it is strong or weak. So for ionic compounds and only ionic compounds, if it is 100% soluble, we'll say it's a strong electrolyte. If it is not 100% soluble, we're going to call it a weak electrolyte. For molecular compounds, though, for molecular compounds, there's only going to be two. So molecular compounds are acids and ammonia. All others are non-electrolytes. And the only strongs are the 6 strong acids, And then just begin to show you down on page, I think it was 5, even though we haven't talked about all of its pieces. That's where your 6 strong acids are. And again, memorize those. Now, there are 6 strong bases, but if you'll notice for what we're talking about, they're all ionic. So they would show up under the solubility rules anyway. All right. We didn't really talk about a lot, but that is a key component for dealing with reactions into the future. So we really need to be able to understand whether it's an electrolyte or a non-electrolyte. All right. Until next time, Jolly out.